And the idea with the chain rule, we'll do a couple of examples and I'll let you do a few problems, is you have to identify that there's two functions. This is a composition of functions. There is a function inside of a bigger function. So when you look at this example, you have to identify, usually what's in parentheses is the function. That's the inside part. And the inside function, we call that u. We use the letter u as an intermediate variable. So what you want to write down is you want to write down what's inside the parentheses. That's the inside part. So we're going to say u is 3x to the third minus 4x to the second plus 6x minus 1, like that. Okay, so we identify that inside part. Okay, you probably won't do the chain rule this way very much. You will do a little bit on your homework, but you'll kind of be weaned off of this method. Okay, that's kind of the idea as the problems get a little more advanced. Okay, so what happens is this thing right here that I'm highlighting in red, that really becomes u. So you're just left with 2u to the 10th. So that's the big function right there. So what you're really doing is you're doing a composition of functions. You're plugging that inside part into 2u to the 10th. Okay, that's what it is. Okay. Now, what you want to do is we're going to do this problem two ways. We want to go ahead and write down the chain rule formula. So you want to write this down. That's dy over dx equals dy over du multiplied by du over dx, like that. Okay, and like when we get into the second test, you'll still be able to write down formulas and stuff. You won't use this formula very often, but if I ask you to use this formula, then you need to do it this way. Okay, so actually it's real easy. You can do this in your head. When I ask you to do dy over du, you're going to this function right here. Okay, I'll try to kind of highlight as they go. And you can do this in your head. What's the derivative of 2u to the 10th? 20u to the 9th, right? Okay, by power rule. Okay, so that just becomes 20u to the 9th, like that. Okay, so we do that. That takes care of that then. And then what we do is we do du over dx. Okay, I'll highlight that in yellow. So what's the derivative of 3x to the third minus 4x squared plus 6x minus 1? And the class enthusiastically responds, okay, 9x to the second minus 8x plus 6. That's it. Okay, good. So you can do that in your head. So that is going to be 9x to the second minus 8x plus 6. That's how you do the chain rule. Now, I'm not done with the problem because I don't want u in the answer. We have that intermediate variable. So what you do now is u is all of this stuff right here. So you plug that in to get the final answer to the derivative. That's the last step you always do, is plug back in for u. So what you're going to get is 20 parentheses 3x to the third minus 4x squared plus 6x minus 1 to the 9th power after you plug back in for u, and then 9x to the second minus 8x plus 6. So that would be your official answer to the problem right there. Okay? All right, but don't forget to plug back in. I don't want u in the answer. The whole idea of this is u is just an intermediate variable to help you keep track of the two functions that are being composed. Okay, does that make any sense what I'm doing? So identify u as the inside part, then identify the big function, and essentially you do the derivative of the big function, 2u to the 10th, you do the derivative of the inside and multiply together. That's what the chain rule says to do. So in practice, you're probably only going to do this if you like doing it this way. I do find some students like doing the chain rule this way, regardless of what the problem is. Probably most of you won't. You'll probably just kind of do what I do on method 2 because it's easier. It saves one step. So go ahead and just write down the problem just for reference. So the problem is 2 times parentheses 3x to the third minus 4x squared plus 6x minus 1 to the 10th power. Okay, now what you do, really, you think about what it would be like to do like the derivative, again, of just 2 times something to the 10th. Okay, you just do the extended power rule. So the way this goes when you do your derivative is it's just like the power rule, but there's one additional step. So you bring the 10 down, multiply by the 2 to get 20, like you're used to doing. You leave what's in parentheses alone. You don't touch it yet. So that just comes straight down. Okay, then that goes to the 9th power. That's what you're familiar with. That's how the power rule works. But since you have a big function inside of a function, the other thing you got to do is you got to remember to multiply by the derivative of what's inside. And make sure you have that you're multiplying. So you just do this in your head. So that would be 9x to the second minus 8x plus 6. Obviously, you get the same answer. You know, the only step that what you save is you don't have to plug that u back in. It's already there. So that's the step that you save. That's the way you're probably going to do the problem is like that. If I just say do the derivative of that, that's how you're going to do it. You do it in your head. Yes. Yes. I mean, this is an example right here. You could only do this problem with the chain rule. What happens on a chain rule is you always have kind of a basic function. For instance, you have what you all have been doing before you learned the chain rule is just, how to do that. That's just x to the 9th. So when you do that derivative, that is a power rule, and then you're done. Okay, the way you make this into a chain rule problem is you change that x to something else. And I could change it to anything. I could change it to ln of x to the 9th. Now when you do the derivative, it goes like this. You would have to bring the 9 down, you would subtract 1 from the exponent, and then you would multiply by the derivative of the inside part, which in that case is 1 over x. So see, what you're doing is you do a chain rule when the functions are more complex. Okay, so it's kind of like you take the basic rule and you extend on it. That's the idea. Okay, so you have to use chain rule on this problem. All right, does anybody have a question about what I did? I mean, that second way is easy. You won't have any trouble doing that. I mean, if you got your basic rules down, you won't have any trouble doing that. Okay, all right, let's go to the next page. We're still going to do these in 2 ways, just to kind of get you the hang of how the chain rule goes. And so with this problem right here, we need to identify the inside function. So what do you think the inside function is? It's inside of a bigger function. What do you think? Yeah, it's the thing under the radical, exactly. That's like a parenthesis, okay? You're going to probably need to change this problem to parentheses 10x squared plus 4x to the 1/2 power anyway. Okay, I mean, that's the way you're going to think of the derivative anyway. So u is the inside part, like that. Okay, so now the big function is, all you're really doing is this inside part just turns into u. We just use that intermediate variable u. So you can write this as square root of u, or you could just write that as u to the 1/2 power. You're going to have to do that anyway. Okay, so you identified the inside and function in the big function. Okay, all right. So now write down your chain rule. So the chain rule is dy over dx equals dy over du multiplied by du over dx. Okay, like that. Okay, just write it down. And then what you do is you do this in your head, say. So what we do when we do dy over du, you're doing the derivative of u to the 1/2 power. So in your head, what's the derivative of u to the 1/2? 1/2 u to what power? Negative 1/2. Okay, power rule. Okay, all right. So that will become 1/2 u. Remember, you're subtracting 1 from the exponent. That's how I'm getting that negative 1/2. So that takes care of that. Okay, and then we have to do the other part. So we've got the dy over du. Now what we got to do is we got to do the du over dx. So that would be the derivative of 10x squared plus 4x. So what's that in your head? 20x plus 4, right? Okay, so that derivative of that inside part is 20x plus 4. Okay, and those are the basic rules we've been working on for several weeks now. All right, what else do I have to do? I've got to do one more thing. Plug the u back in. I do not want u in the answer, so that means you just plug it back in. Okay, so what we'll have here is we'll have 1/2 parentheses 10x to the second plus 4x to the negative 1/2 times 20x plus 4 like that. Okay, and that's good enough. I mean, we've learned that we can do certain things with this. We could, move the negative 1/2 power down to the bottom to make it positive. I'm going to go ahead and do that on this problem because it's just always kind of good to see that. Because students sometimes struggle with this idea a little bit. What you would have, if you put 20x plus 4 over 1, that 20x plus 4 is going to be on the top of your fraction. It's not in the bottom, it's on the top. The 2 is in the denominator. So now if you bring the negative 1/2 power to the bottom, you would end up having 10x to the second plus 4x to the 1/2 power, like that. Okay, so the only thing in the denominator is a 2, so you bring it down to the bottom to join that. And then you can change that back to a square root, like this. And then you would have, that's usually the form I like these things to be put in, is back in a radical like that. Okay, I wouldn't fuss if you gave me that final answer at all. There is one other thing you could do with this problem, though. Just algebra. Any thoughts? You can take a 4 out. Good. Okay, you could take a 4 out of the numerator. If you did that, you would have 5x plus 1 all over 2 times the square root of 10x squared plus 4x. Okay, so it's good to kind of learn how to do the simplification. Anytime you have a fraction, the only way you can simplify it is to factor, and then what you'll find is the 4 divided by 2 is 2. So you can do that, and that's the only way you can accomplish that then. So actually, the best answer on the problem would just be 2 parentheses 5x plus 1 over the square root of 10x squared plus 4x. So, I mean, I would take, this answer, I would take that answer like that. If I don't want you to change it back to a radical, and if I'm okay with you having a negative exponent, you can give me that answer. That just kind of depends. But I'd like you to go that far just to kind of practice your algebra skills. Okay? Do we have any questions? Okay, all right. So let's do this with the extended power rule then, the general power rule. So what we're really doing is y equals 10x to the second plus 4x to the 1/2 power. Okay, so most of the time you're just going to do like this, which is the chain rule. If I say general power rule, it's the chain rule in your head is what it is. So when you do this derivative, this is going to go like this. Okay, you bring the 1/2 down. You leave the 10x squared plus 4x alone. You subtract 1 from the exponent, which you can do in your head. Okay, so that becomes negative 1/2. And then what else do you have to do? Multiply by the derivative of the inside part. Exactly, that's what you can't forget. So what goes here is the derivative of the inside part, which you can do in your head. So the derivative of 10x squared is 20x. Derivative of 4x is 4. So you're going to notice that we get the same answer there that we got right there. Just had all that in your head. You just didn't have to process any other parts of the problem. Okay? All right, any questions? Okay, all right, let's do a few problems and see how we do. So these, what I want you to do with these problems down at the bottom is do the two methods. Do the U and Y like I showed you, and then do just the general power rule, and you want to see that you get the same answer. These problems are very similar to the ones I just did. So just these two problems down at the bottom is what I want you to work on. Okay, I'll come around, give you some help, work together, compare answers, and so you can kind of see if you're on the right track. You'll pretty well know you're right if you get the same answer twice. Okay. It's always good to just start with, the inside part. That's what's inside the parentheses. Just write that down and then get the big function like that. So I do want to mention one thing on here. When you do this second problem, get your answer. I want you to just kind of go all the way with the algebra. Get your answer with a radical. Go ahead and take it that far. Come around. What do you do? Okay, first one's okay. That's right. Okay, first one's good. You got the same answer twice. Okay, the first one's probably a little more straightforward than the second one. The only thing is make sure you replace the U. Oh, right. U back in. So you got that one okay. You just got to place the U back. The first one, all right. Same answer both ways. Yeah, you're okay on the second one. Okay, so that's good. Okay, that's good. So you're doing that right. Now, what you ought to do is just go ahead and multiply 100 times 2 and get 200 times 2x minus 13 to the 99. Okay. You got that. You're going to try to do that the other way. Outside. Yes. Okay, but you identify the inside part. That's the start. Okay, so what you want to do on that is you've got y equals 2x minus 13 to the 100. Okay, the inside part is the part of the parentheses. Okay, so that's a good start. Now, what do I mean by the y? You're just going to replace that thing with u. So what you're going to have u, the 10th. Okay, that's all you do. The big, not the 10th, the 100, I'm sorry, that's 100 power base 12. Okay, got that. All right, understand that okay? All right, now, you should write down the formula. You have dy over dx equals dy over du times du over dx. Right, that's a chain rule formula. Now, what you have to be totally solid on is, do you have the rules down that we've been working on the last couple of weeks, okay? So what's the derivative of u to the 100? Power rule. Okay. And then 100 u to the 99. Okay. So that's stuff you have to review and you got to make sure you're getting down by now. How about the derivative of 2x minus 13? What that is? Okay, anytime you do a derivative of a number times x, the number in front is the derivative. Anytime you do a derivative of a constant, that's 0. So the derivative of that's 2x. Go back to your algebra background. That's a line. That's y equals mx plus b. That slope is 2. So you get 200 u to the 99. Okay. Now, the last step, when you do that chain rule, you got to plug that back in. So you get 200 parentheses 2x minus 13 to the 99 power. That's your answer. That's what's got to start the process. You're thinking on those basic derivatives, so you've got to get to a point where you're all the basic rules we learned that you have to get those things. Okay, does that help? Get you started. Okay. All right. And then the next one's the same. It's the inside part goes under the radical, and just you can kind of begin to put that together.
No, but that's outside of the bracket.
Oh.
Okay, you got answers, okay?
1/3. So it's 3 times cube root of r. And I don't think we can simplify that.
Yeah, also if you got one, those things are always posted too. So, if you miss, you just need to print them out. Okay, you got good results. And the only thing I want you to do with this is the derivative of that is 2, not 2x. Okay, so you've got 2 and not 2x, and then you would just multiply together to get 20. So you would have 20 times 2x minus 13 to the 99. Okay? Yes, 200, I'm sorry. Yeah, 200. Okay. Yes, that's good. Okay, go ahead. Help these, Randy, help these. You see how they did that? Yep. I think that's what I got. Except that's a 8x. No. It's a 4x. You're okay. You're okay. Yeah, is that what you got?
Yeah.
Yeah, that's right. Okay. Okay. Okay, how you doing back there? Okay, you're doing that beautifully. The only thing you need to do is just go ahead and multiply 100 times 2 and get 200. You can do that. So you have 200 times 2x minus 13 to the 99. Okay. And then this one, you're on the right track. You're just not doing this derivative. When you do the derivative of u to the 1/3, it's going to come down. When you do the derivative of u to 1/3, you have that thing right there. That's 1/3 u to the 1/3 minus 3/3. So that's 1/3 u to the negative 2/3. Well, you're going to. Well, no, that it may be at the end of the problem, but right now, when you do this formula, you do the derivative of the inside part. You did that right there. But what you didn't do is you didn't do the derivative of u to 1/3. That's what you didn't do. So when you do dy over du, you have 1/3 u to the negative 2/3 times, and you did the derivative of the inside part. All that, so you didn't do that. You just, that right there, what you're not clear on, I think, is if you have a third root. That's u to the 1/3. And you wrote that right there, but when you do that derivative of u to the 1/3, you get this. It's not that. I did that. 1/3 down, subtract 1 from the exponent. And what you got to do is you got to plug that u back in to get your final answer. Parentheses, just whatever that inside part was, to the negative 2/3. And then times the inside part. Okay. Try to get that other way. So that helps us. Okay, how's the back row doing here? Okay, got a good answer on the first one. You all got the same answer on the first one? Okay. General power rule is just going to write 3x to the third minus 4x squared to the 1/3. Same thing. You just bring it down, leave that alone, subtract 1 from the exponent times the derivative of what's inside. Same thing. Same concept? Yes. Yes. Stays on top. So you get the same answer. There we go. That's the same answer. You're saving yourself a step. So now you guys get the same answers. Okay. Good. Which way road is the problem? First way or second way? Either way, they're both equally easy. They are. The only thing in the second step is it just saves you from plugging in the U, but it's exactly the same thing. Okay, so let's go ahead and let's run through these. Let me put up the answers here. So, the thing that happens too, in a math class too, if you're kind of shaky on your basic derivative rules, it's going to affect you. So you have to make sure that you're getting down all of these rules that we learned, seriously. My power rule, derivative of logarithm, everything. Okay, you have to keep going with that kind of stuff. All right, so let me go ahead and just display the answers. I think I pretty well helped everybody with the first one. I don't think there was as much trouble with the first one. So does anybody have a question about number one and how that goes? Okay, in practice, most of the time what you're going to do, and you're just going to do these problems in your head, it's just, bring the 100 down, subtract 1 from the exponent, do the derivative of what's inside. Okay, so, and then again, a lot of you didn't multiply 100 times 2. Is it wrong to not do that? Not really, but it's preferred that you just do basic simplifications when they pop up. So you would end up with 100 times 2. That's where you get the 200. Okay, so that's the idea there. The next one was maybe a little bit more complex with the algebra, but the inside part, everybody knows what I'm talking about by the inside part. The big function is that inside part, u to the 1/3. So really, when you do the chain rule, just think of it this way to kind of simplify the thought process. You're doing the derivative of the y term, so that's the 1/3 u to the negative 2/3. Then you're doing the derivative of the 3x to the third minus 4x squared. That gives you that. That's it. That's all you're doing is you decompose the function into two functions, a function y and a function u. You do the derivative of each part and multiply. That is what the chain rule is. It's decomposing a composition of functions. That's the reason the last class we went through and reviewed composition of functions. So basically, when you substitute in, you would end up having this. Right there is your derivative right there, okay? And the only thing with that is, the thing that I did want you to try to do to make sure that you're on top of how to do this is make the negative exponent positive. So that's why I wrote that in the fraction like that. And then you can change the 2/3 back to a radical like we've learned to get that final answer. So I do want you to, make sure that you're able to get to that final point like that. Okay? All right, so I think we did pretty good. I think the idea on that went pretty well. Okay, any questions with anybody on that? Okay, so what's going to happen is in this section, the algebra is going to get a little bit more complicated. You're just going to see that. But if you can do the algebra at this level, then the algebra is not going to get any more complicated the entire semester. I promise you that. There may be different things that are going to pop up, but we're getting to the point where the algebra is getting about as advanced as it's going to get, okay? As we finish this section, that is. I haven't done those kind of problems yet, but that's what I'm going to get to next. All right, so like I said, you'll be better at your algebra by the end of the semester. You have no choice, okay? It's the way it is. All right, so let's go to the next kind of idea here. And we're going to get away from that U-Y thing, and the purpose of that is to help students think about the chain rule. The chain rule is always when you're taking a more advanced function and you're just expanding on a basic rule that you've already learned. Okay, so when you look at doing the derivative of e to the 10x squared minus 5x, it's a lot like this, okay? Hopefully everybody has memorized the derivative of e to the x is e to the x. If you don't, you got to memorize it. So what happens when we do the chain rule, it's almost the same thing, okay? Just think of it like this. When you do the derivative of e to some other power, it's itself times the derivative of what's inside. The inside part is the exponent, okay? So again, without going through and doing the u and y thing the way I showed, it's just as well to do it like this and try to think of the chain rule like this. So when you do the derivative of this function, okay, first of all, you know the derivative of e to the x is itself, right? So you write itself, 10x to the second minus 5x like that. Then you multiply by the derivative of the inside part, which is the part that's inside the exponent. And you can do this problem totally in your head. You don't have to necessarily write that step out. But I want you to process it by just thinking itself times derivative of what's inside. Okay? So the final answer of this problem is going to be itself, e to the 10x squared minus 5x. And what's the derivative of the inside part? 20x minus 5. Problem done. Okay? Now, you probably want to have that 20x minus 5 in parentheses, because if you don't, then you're not really writing that answer correctly. That e is being multiplied by the whole thing. Okay, that whole thing's got to be in parentheses. That's fine. That's a good answer right there. This is unnecessary, but it's not wrong to do this. You could take a common factor of 5 out of that if you chose to, and if you did that, you would have 4x minus 1. You don't have to. There's no law that says you have to do that. But it's good to be aware of things like that. Okay? All right? So that's how you do that. So when this pops up, what you all want to try to learn when you're learning the chain rule is there's always a basic rule. We know the derivative of e to the x is itself. But if I change that x to something else, like if I was doing the derivative of e to the ln x, here's how it goes. It's itself, right? But it's times the derivative of the exponent, which is what? 1 over x. See, that's it. You're taking a basic rule and then you're expanding on it. That's why you multiply by the derivative of that extra part. That's what the chain rule is, okay? That's the way you're going to do that. You're going to learn to do problems like this in your head, okay? All right. So before I go to the next thing, let me just check you on this. If you had the derivative of e to the x squared, what do you think that is? There you go. It's itself times the derivative of the exponent. That's it.
As the next step, e to the ln x over x?
Yes, yes. You wouldn't have to, but you could. Okay? All right. That's it. Okay? Now, let's move on to the logarithm. Okay? So again, the idea is there's always a basic rule. We know the derivative of ln x is 1 over x. If you don't know that, well, you need to get it down, okay, because it's going to keep popping up, okay? So what we do is now we're doing ln of a function. So it works the same way. The general rule is this. It's just instead of 1 over x, it's 1 over the function, okay, like that. That's half of the problem right there. What else do I got to do? I got to do the derivative of the inside part like this. Okay, so I end up getting 1 over 2x minus 5. Derivative of 2x minus 5 is 2, right? Okay, now you should multiply this straight across to get 2 over 2x minus 5. So that's how you do a derivative of a logarithm of a function, okay, without having to decompose and do the y and u thing, okay? That's the idea. So let me just kind of check you on a couple of things as I go through this, okay? Let's say you were doing the natural log of 4x. Two-step process. What is it? 1 over the function times the derivative of what's inside, which is what? 4. There's your derivative. Now, you could cancel out the 4's on that. You do whatever algebra you can do. Okay, so that's the idea. So what if you had ln of e to the x? What do you think that derivative is? 1 over the function times the derivative of the function, which is e to the x. Well, that would be 1. That'd be 1. Okay, so that's how you do that. That's the chain rule. It's just the big rule times the derivative of the inside part. That's the way you think of it. Okay, the process of doing the u and the y thing is to help train you to think this way. There's always an inside part to a bigger, badder function. That's the idea. Okay, so let's look at the bottom here. I forgot to bring my Russian doll. I'll go get it at break, okay? Because one of the best ways to help students understand the chain rule is Russian dolls, okay? Because they are things inside of things. They are functions inside of functions. So like we had a teacher here, a professor, it was from Russia, and she gave me this Russian doll and said, this is the way you need to teach the chain rule. And I thought, that's a great idea. So the idea is you're always taking the derivative of the whole doll, then you're multiplying it by the derivative of what's inside. And if there happens to be something inside of that, then you multiply by what's inside again. So theoretically, you could have chain rules with an infinite chain of functions inside of functions. We're not going to focus too much on that. We're going to focus mostly on a function, one function inside of a function. We might do a function in a function in a function, but nothing more than that. But that's the idea of what the chain rule is. So it's just kind of like you got the big function, you got the inside part, and then if you had another inside part, you would just multiply by it. And that's a weird looking formula, but that's what that is saying. Okay? Okay, let's go to the next page and let's go ahead and work this out and work these two examples out right here. And again, we're not going to do the YU thing. We're just going to think about what is the inside function. Well, the inside function is that thing right there. It's inside of another function. So just write down the inside function's 2x over x plus 1. Okay, so what's the big function then? It's really u to the 5th. Okay, that's the way I was originally teaching you how to do that. So what you do is you always start with the derivative of the big function. Okay, we're just going to do this as much as we can in our head. Okay, so here's how you start. You always see that the big function is something to the 5th power. Real simple question. How do you do a derivative of something to the 5th power? Bring the 5 down, subtract 1 from the exponent, multiply by the derivative of what's inside. So you start the problem this way. You bring the 5 down, you leave the 2x over x plus 1 alone to the 4th power. Okay, like that. Now that's not the answer. The chain rule instructs you to do the derivative of the inside part. Okay, like that. Okay, so we do have to do that derivative. All right, but that's how you start it. All right, now let me ask this question. Okay, you've been doing your homework and stuff. How did I teach you how to do a derivative of a fraction like that? That's the quotient rule, right? Okay, so you got to start putting all these rules together. That is a quotient rule. And the quotient rule, you don't have to write it down, but if you want to, that's bottom times derivative of top minus top times derivative of bottom over bottom squared. We talked about that last week, okay? So what we're going to do when we put this derivative together, I'm going to bring this down. I'm still just going to have 5 over 2x over x plus 1 to the 4th power. Now we're going to throw this, the 2x over x plus 1, into the quotient rule. Okay? All right, so watch carefully how I do this. The bottom is x plus 1. Okay, we do that. Okay, what's the derivative of the top? 2, so that's times 2. Okay, again, just following what the quotient rule tells us to do. Then it's minus the top, which is 2x. And what's the derivative of the bottom? 1. Okay, so that's bottom times derivative of top. And then it's the bottom squared. So you just put the bottom squared like that. Okay, so that right there is the derivative. The calculus of this problem is done. but we do need to simplify it. So now we got to do algebra. Okay, so let me show you how the algebra goes there. Is everybody okay with what I did with that? Okay, always think of the big function as where you start, then you have to do that derivative of what's inside. Okay, so here's a couple of things that I recommend that you do. You don't have to write down what I'm doing here, but these are some algebra things sometimes students don't know. Okay, if you have a fraction to a power, then really the numerator is to the power and the denominator is to that power. I'm just showing you that basic example. That's how you deal with fractions. So you're going to bring the 5 down and just write this as 2x to the 4th all over x plus 1 to the 4th. Okay, we can do that. Okay, if the entire fraction is to the 4th power, both the top and bottom are to that power. Okay, all right, now we'll do this. Just distributive property, 2 times x is 2x, 2 times 1 is 2, and then 2x times 1 is minus 2x. Then we have the bottom squared like that. Okay, so I'm just doing a couple of basic algebra things to get us through this then. Okay? Okay, now let's think about this part right here. If you're doing 2x to the 4th, you can do this in your head. A lot of students aren't sure how to do that in your head, but what does it mean to take something to the 4th power anyway? Multiply it out 4 times, right? So if you have to do anything on scratch paper, just do it on scratch paper. If you do 2 times 2 times 2 times 2, that's 16, and then you would have x to the 4th. That's what it is. That's what it means to raise something to the 4th power. So that becomes 5 times 16 x to the 4th, and then we're still going to leave the x plus 1 to the 4th alone for now. Okay, so that's the algebra that pops up there. Now, if you look inside of your parentheses here, what do you see happening? What's the basic thing that happens? 2 x's cancel, right? So what you're left with is you're going to be left with 2 over x plus 1 to the 2nd like that. Okay? Now, when you're learning arithmetic, how do you multiply fractions? You multiply straight across, right? So you multiply the numerator straight across. You could use your calculator. 5 times 2 is 10. 10 times 16 is 160, like that. Okay? Now, here's the other thing that pops up with students. And again, hopefully we're getting better with this as time. What do you think x plus 1 to the 4th times x plus 1 to the 2nd is? There you go. Good. It's just adding exponents. That is no different conceptually than having x to the 4th times x to the 2nd, where you add the exponents. So this part right here, you can put that together and you just get x plus 1 to the 6th power. And yeah, I want you to go that far. That's you have to go that far to do the applications that we're going to be learning, a little bit later on down the line. Okay? So what I find in these kind of problems is generally if students know how to start the problem, generally they're okay with the calculus part. And that's it. The rest of it's just algebra. Okay? Do we have any questions on that? Okay. All right. The next one is it can be a little challenging. The algebra part can. All right. So let's go down. Let's take a look at this one. You have to always know where to start on these problems. So what I see on this problem is I see a function multiplied by a function. That's what you have to see because you got to know which rule is going to apply to this. All right. So I see 2 functions multiplied. What is the rule we learned where you do a derivative of 2 things multiplied? The product rule. Exactly. So you have to use the product rule on this problem, and you have to start that way. Can't start any other way. So the big function is actually 2 functions multiplied. The product rule, if you want to write it down, is first times derivative of second plus second times derivative of first. Okay, so that's what we're going to plug in is that. Okay. All right. Now, you can do this first step, some of it in your head. I'm not going to do it in my head. I'm just going to put this in the formula. So the first, you just write it down. Then we're going to multiply by the derivative of the second. We'll do that in the second step of the problem. So for now, I'm just going to write it down. Okay. And then we have the second. You always have a plus sign, then the second. And then multiplied by the derivative of the first. Okay, like that. So that's in the product rule right there. Just write down first times derivative of second plus second times derivative of first. Okay, now we're at a point now in this class where you basically have now officially learned every derivative rule that I will teach you the entire semester. And I don't know how many I've taught you, maybe a dozen probably or so. We're pretty well done with that. So now you're starting to put this all together. Okay, so we have x plus 2, that comes down. Now this thing right here, I hope you recognize that's a problem you did in class today, the same kind of thing. So what do? You do the chain rule. So you bring the 3 down to the second power, multiply by the derivative of what's inside. Okay, so when we do this part, it's going to go like that. That comes down. You leave the x squared plus 2x alone. That goes to the second power. And what else do? You do the derivative of the inside part. So what's the derivative of the inside part? 2x plus 2. There you go. Okay, right there. Okay. All right. Now, the rest of the problem. We bring the plus sign down. We bring the x squared plus 2x the third down. Now, what is the derivative of x plus 2? 1. Okay, that's 1. Okay, so that right there is your derivative. Okay, the calculus part of the problem is completed after the first step. Okay, any questions? Okay, now this is all about factoring. The next thing that we have to kind of look at is factoring on this. So this is the algebra. Watch very carefully. Okay, whenever you do the product rule, you end up with 2 parts of the problem being added. I'd recommend that you draw a box around those 2 parts because it'll help you process this better. Okay, so what we have to do here, and this is the part of the problem that students have the most trouble with typically, is look at those 2 boxes. What jumps out as you as what's the same in each box? Yeah, I got this part right here and that part right there. They're the same, aren't they? Okay, but one of them's to the second power and one of them's to the third power. So which one comes out? Lowest exponent, lowest exponent. That's something you learn when you learn how to factor. Okay, and that's a worthwhile note to write down if you need to. You take out the lowest exponent. Okay, like that. That's the only thing that's in common. Nothing else is. Okay, that's all I see. I've got x plus 2, I got 2x plus 2. Those are totally different. 3 and 1, totally different. So what you do is you take out, you write down that common factor, which is x squared plus 2x to the second power. Then you draw a real big bracket there, and we have to fill in what goes inside. Now, it depends on you. Some of you may have good enough algebra skill where you could figure out what goes inside of the bracket totally in your head. Okay, some of you are probably not that skilled yet. So this is what I recommend. Okay, what I recommend, and yeah, it takes a little bit more writing, but who cares? Your goal is to get this right. So we have times 3. I'm going to write down the problem that I'm factoring. And I'm going to write it down directly under these brackets and show you. I've shown you this before. And you could also do this on scratch paper if you wanted to, like that. Okay, so I just write down the previous step underneath the brackets. So a good way to process what is left over is just take that previous step and divide each piece by the common factor. Okay, so I'm just going to kind of write it that way. That way, visually, you can kind of see what's going on in the problem. Okay, so that's something that I highly recommend for a lot of students to do. They like that. Okay, now, if you look at this part right here, look what cancels. That cancels, so just go ahead and cancel that out, and then write what you're left with. Okay, you're left with x plus 2 times 3 times 2x plus 2, like that. Okay, that's what you're left with if you take the common factor out. Okay, now you're left with that plus sign. So what happens on this? One of them cancels, right? You have 3 on top and 2 on bottom. So you're going to be left with one of those. So you're left with x squared plus 2x. And you're left with the 1, although you don't have to put that there. Okay, does that make sense? Okay, if you got 3 on top and 2 on bottom, then you got 1 left on top. All right, now that's not the answer. We still got one more thing to do, right? Yeah. Oh, that's a 2x right there. Yeah. So that right there needs to be a 2x. I just saw that. Okay, so we got that. All right. Now, what we got to do is we got to multiply all this stuff out. So we need to really FOIL all this out. And this stuff right here, you can always do stuff on scratch paper. There isn't anything wrong with doing that when you're doing a bigger problem like that. So I'm just going to kind of do some of this work over here, over at the side here. And it doesn't matter what order you put this in. I'm going to just go ahead and FOIL out the x plus 2 times 2x plus 2. And then you can multiply the 3 out later if you want to. Okay, so that's what I'm going to do. There's several ways you can do this. So the way I'm going to do this is just FOIL this out. So that is 2x to the second for the first term, plus 2x for the outside term, and then plus 4x for the inside term, and then plus 4 like that. Okay, then I'm just going to distribute the 3. I'll get 6x squared plus 6x plus 12x, and then 3 times 4 would be plus 12, like that. Okay, and there's more than one way to do this. This is just what I decided to do. You got to FOIL and distribute the 3. So what I'm getting is 6x squared plus 18x plus 12. That's what I'm getting. That's what the result of all that is, and that's stuff that you all know how to do. I know you do. I've seen you do it all semester. FOILing is something you've been doing, okay? So here's what we do to finish putting this whole problem together then. Okay, that comes down. So you've got your common factor. Okay, this part that I have in yellow, I did that the side of my paper, and I got 6x squared plus 18x plus 12 there. Okay, now this part right here just comes down. Don't forget about this part here. That comes down. So that is just plus x squared plus 2x. Like that, and then you've got some like terms to put together, and then you're finally done with the algebra on the problem. So this comes down, you get x squared plus 2x to the second, and then this stuff right here, when you put that together, you're going to have 6 plus 1 is 7x to the second, 18 plus 12 is 30x, and then plus 12. Okay, future test problem. That's a test 2 problem right there. Okay, I want students to know how to do that, because if they can, then I feel, you know, these 2 problems I just did, then I feel like the algebra skill is beginning to come together. Yes. 20x, not 30x. Thank you. I don't know why I did that. I think I said 20x too. Okay, so that's your answer to your problem right there. Okay, the hardest part's the algebra, not the calculus. All right, and you can do little things at the side of your paper. You know, you don't have to do this division step if you can do it in your head. That's up to you. But most students I find in this class have trouble doing that in their head. So that's the way you want to go about doing that. All right, well, we're going to work out a couple of problems, then we're going to take a break. I don't want to give you a break now because you're going to forget what I just showed you. When you come back in 10 minutes, you're going to already have forgotten, I'm afraid. So to wrap this section up, go ahead and see what you can do on these 2 problems. You'll probably need to work together, and you're probably going to need a little help on this, so we'll see how it goes, all right? So just get going on it and see what you can come up with. Try to simplify as far as you possibly can. So essentially, I've given you one of each problem I just showed. They're both kind of constructed the same way. And look at the example you took down. When you do this number 1, look at the problem that I did on the previous page that's like it. It's almost the same, except you got to deal with that E thing. That's the only thing that makes it any different.
That's right. Okay. Yeah, no, that's right. Yeah, you are right. I mean, all you gotta do is put that together, when you multiply straight across. You do not have to distribute that.
Oh, I don't?
You could if you wanted to, but I'd prefer that you just leave it in the factored form. So you would have the 3e to the 2t, parentheses, there we go, you're right. That's right. That's right. Okay, let me see what you've done so far. Okay, you've got that right, and you did the, yeah, I think you're doing okay. That would be, those are like terms. You have minus 2e to the t over t minus 1 to the second.
Okay.
That's what you got. She's got a right answer. If you want to get an answer, you can see if you got what she's got.
Alrighty.
Okay, so a couple of things. See, this is not quite right. I mean, you did your product work and your question were right. but you didn't do this right. Okay, that would be t e to the t minus e to the t minus e to the t. That's what that numerator is. Okay, that's what you got wrong. That is not e to the t. That's t times e to the t. Those are like terms, so that would be t e to the t minus 2 e to the t over the Father squared. That's it. Now you want to kind of take it from there and then kind of see what you came up with there. Okay. Okay, let's see what you started off with here. Okay, you did kind of what I just saw him doing. So you got, make sure that when you're using that quotient rule, that needs to be in a parenthesis. Okay. So now when you distribute, that will be t e to the t minus e to the t is what that is. And that is minus e to the t. So those are like terms. So the numerator from the quotient rule would be 2 t e to the t minus 2 e to the t. Okay, so yeah, she's got the right answer. I think they both worked out. You got the right answer. Got anything on the first one? Okay. Yeah, you're right. The only thing that I want you to do further is just multiply straight across. So you would have t minus 1 to the fourth, and that numerator, you do not have to distribute the 3 through it. You can leave it in that factor form. And you got it. Okay? Right? So almost there. Okay, let's see. You got bottom times derivative of top. Derivative of the bottom is 1. Right? Derivative of t minus 1 is 1. Is 1. Derivative of t minus 1 is 1. So what you have is you've got t minus 1 times e to the t minus e to the t times 1. That's what you have. Okay, now when you multiply that, that'll give t e to the t minus e to the t minus e to the t. Okay, over the bottom square. That's what, then you need to kind of see if you can do a little algebra there. You almost got this. That's the only thing I'm seeing anybody do. So. Yeah, okay. So you got just you don't have 2. So distribute, so that would be t e to the t minus e to the t. T e to the t. Yeah, because we're just taking e to the t times t. So that will be t e to the t. There we go. Minus e to the t, because you're doing e to the t. And then you've got the other e to the t all over the t minus 1 per second. There you go. That's your derivative right there. You just need to clean it up a little bit. So you would want to do the numerator to the second and the denominator to the second. Okay, so you have, and if you do e to the t to the second, that's e to the 2t. We talked about that. E to the 2t. E to the t to the second is e to the 2t because you multiply together. And then just bring that other part of that down. E to the 2t, you're done with that. And then just bring that other part, so you would have t e to the t minus 2e to the t. Those are like terms. And then you just multiply your fraction straight across. Yeah, okay. Now that's a time sign right there. That looks to be like the right minus. That's time. Okay. Now, so you're doing your function rule, okay, but make sure that's your no, it's positive. Yeah, because when you did the quotient rule, you're doing the bottom, so you're kind of confused because right there, when you do the chain rule, it's times the derivative of what's inside. Okay. No, because the bottom, if you multiply straight across, you have t minus 1 to the 4th. And then the numerator, you just write that times parentheses, all of that. You don't have to distribute the 3e to the 2t's out. Yeah, just write it like that. Okay.
Is this one or the first one?
You got it.
So it's add t minus 1 squared.
No. You cannot cancel
Yeah,
because
you just
of
have
the
to multiply the 2 for the t, so it would be 3 times e to the 2t. Gotcha. Thank you.
Not quite, because when you do the derivative of the second, that is 3 times x
Second, I did a chain rule.
times the derivative of x
Plus,
plus. That's how extended
the
power.
first one times the second.
You're not quite doing the product rule right. Okay? What you're doing is you're trying to do the derivative of the parts. When you do this problem, you want to do the product rule.
I like this.
So it goes like this. So first is 2x
Here's
minus
the x
1
plus 1 squared.
You're not ready to do the derivative. The derivative of this
This
part
up here,
is 3
the 2x
times
minus
x
1
plus
here.
second times the derivative of
The
the
second
second.
part, I have the 8.
Then you do it backwards, then you do plus the
And
second.
I just have x plus 1 like this. X.
Now we do 2 times
So I have that.
2x minus 5 first times the derivative of the inside. Okay? They want to kind of think through what I wrote down. Yeah. I just want you to know so much.
No, I didn't see that. Yeah.
Now, the only thing you do with a quotient rule, it's a minus sign. Bottom times derivative top minus top times derivative bottom. Okay. Now, kind of like what you want to do on this is the 3 comes down, and you're going to do the numerator to the second power, and you're going to do that denominator to the second power. Yes. Now, this right here, you just distribute, so you have e to the t times t is t e to the t. That's all you do. E to the t times 1 is minus e to the t. And then this part right here would be minus e to the t. Okay, now that's to e to the 2t, if you multiply the exponent. So you're going to have like 3 e to the 2t.
Just trying to write that.
Over here, you're going to have.
Yeah, but I didn't notice that these two x out.
Over t minus 1 in the second. And then you just multiply straight across. So if you multiply straight across, you take that times that, you add the exponents up to get this. And then the numerator, you just write it like this. So you're on the right track with the second one. You're just going to do it's not quite to the algebra part yet. But you know, you've done the first, you forgot about that second power. You just write the first as it is. And you got your derivative of your second, you got the second, and you got the derivative of the first. But the derivative of the inside is 2. Okay. You want to try that again? Right? Okay. All right, a couple more minutes and I'll put up the answers and just wanted you to go through it. You guys got it okay? Okay. All right, so you know that's how you start. You know the quotient rule. Remember the quotient rule? So, you know, that's the key part that you have to have is that quotient rule. All right, so your quotient rule is you have the bottom times derivative of top minus top times derivative of bottom over bottom squared, like that. So when you started the problem, go back to where you did that. So you've got 3 e to the t over t minus 1 to the second. Now, when you do the derivative of this inside part, you follow exactly what it tells you to do. Right down the bottom, in parentheses. You do the derivative at the top. You guys know what the derivative of e to the t is? The t, there's another basic rule. So you got to get all of those things in. You have to. Now we do the top. That's e to the t. Derivative of bottom. Do you know what the derivative of t minus 1 is? Number in front. What's the number in front of t? 1. Okay. So there's another basic rule. So things are kind of piling up with the rules, that's what you gotta get down, and then you got the bottom square. That right there is your derivative. Okay, now it's a matter of when you simplify this, you're going to do e to the t squared over t minus 1 to the second. That's what I was talking about. You do the numerator and denominator separately. Okay, and then over here, you're going to do a distributive property. Like that. And then you want to just do a couple of basic things to finish that up. Okay. So you know, it's the rules. One thing you all need to do is, you know, come on my office and we write down every single rule there is, so you can have that to refer to. Because that's what helps. We have all the rules down. Okay, the second problem, if you have 10x minus 11 somewhere in your final answer, then you probably got to where I wanted you to get. I'll do that one in just a minute, because these problems, I just want to give you a little bit of time to work through them in class to kind of get an idea. So you had it right there, but you went too far. What you want to do is you just want to leave those things in a factor form.
You got it?
Gotta get a good job.
Oh.
I was like confused.
Yeah, those are ones you factor out, so you'll take out x plus 1 to the second. I'm gonna put that up here in just a minute. So, I mean, you're on the right track. I think you got one little mistake in there. Okay, well, so I gave a little time just to kind of, to see how far you could go with that. These things you gotta work on. It's hard to do these 100% right the first time you see how these go. So let me just put these up here, and you can get these things kind of written down if you need to, and then we'll take a break. So let me just display those, and I want to kind of talk through the major parts of the problem. So with this one right here, the first one, now I helped a lot of people with that first one. There was, you know, this part right here, that's where you're pretty well done with your derivative right there. And again, what I've done there is I collected like terms. So we know that there's things like this, e to the t to the second is e to the t times 2. So that's e to the 2t. That's something we've talked about before. That shows up. All right, and then basically it's just a matter of multiplying straight across. So you've got t minus 1 to the second times itself is t minus 1 to the fourth. So that would be your final answer on that, okay? And I did that maybe in a little bit different way. I did factor that out, and I don't know why I did that. I didn't have to factor that out. So I think some of you have this answer, which is okay, 3e to the 2t, parentheses, t e to the t minus 2e to the t over t minus 1 to the fourth. I think that's what most of you have, because when I was helping you, that's kind of what I was saying. You can stop there, and you can. Okay, when I was working this out, I did that a little bit different way. Okay, so you want to get that written down on that, and I think how many people? I think a lot of people finally got that. Okay, it looked like we got to that point. The second one is, you know, one you're just going to have to work on. But the first thing that you want to check on here is that we have the first times derivative of second. So this first step right here is your product rule. You got the first times derivative of second's in red, plus the second times the derivative of the first is in red like that. So you want to see that you got that, because if you got that, then you're doing your derivative fine, okay? Now, when I do the common factor, I like to just draw a box around the two parts of the problem and then identify what's the same. So what's the same is you have a 2x minus 5 and a 2x minus 5. You take the one with the lowest exponent out, like that. You also have an x plus 1 and an x plus 1. You have a second and third power. You take the one with the lowest exponent out. Okay, that's your common factor when you do that. And then what's going to be left inside is 3x plus 3 times 2x minus 5 plus 4 times x plus 1. So what I've done from there is distributive property. So you can see I got 6x minus 15 and 4x plus 4. Then I collect the like terms.
Okay, that's the factoring part right there. If you got like to this second step there, then you've got the calculus under control. Because that is really applying the product rule and the chain rule at the same time. Okay, I'll leave that up there. You can get that written down. We'll go ahead and take a break until 1:30, and you can take a picture or get that written down. Okay, so like I said, this is kind of where the algebra is going to get about as complicated as it's going to get. So if you had a little trouble with that, that's pretty normal in this class when you learn this to have a little bit of issue with the algebra because you're not used to it. You didn't do college algebra. You didn't do algebra at this level in college algebra. You just don't. So you learn it now. Okay? All right. Go ahead and take a break.